Well, welcome to a review of graphing and graph parts and a bonus section called How to Read a Speed Time Graph. This is a quick reminder, all graphs, no matter the type, need the following. They all need a title. Graphs that we use in science class all need a y-axis, that's a horizontal axis going up the left side of the graph. As a rule, that's where the dependent variable is graphed. And this needs to be labeled with what the dependent variable is. And they all need an x-axis, which is the horizontal axis going across the bottom of the graph, and that is generally where the independent variable is graphed. Now, we've talked about all graphs needing a title, and what I found is 7th graders in particular seem to think that graph titles need to be like catchy movie titles or book titles. They need to be short and maybe have an exclamation point, and that's not the case at all. The important part about titling a graph or a data table or any scientific display of data is that the title should be specific and precise as to what the graph or data table is about. Oftentimes, these are almost complete sentences. For instance, here is a data table straight out of a scientific paper. Notice how long the title is. Table 1, baseline characteristics of Ishmael strokes, cases, and controls. Again, I'm not sure how that's even pronounced, but this tells everything that this data table is about. When you construct a graph or a data table, it needs to have a title, and the title needs to tell me exactly what the graph or data table is about. Don't worry about trying to save lines or save space. Put every word down that is needed to fully explain. We basically use two different types of graph in science class this year. The first we'll talk about is a bar graph, which is probably the graph you've learned how to do earliest in your life. Let's take a look. Again, we've got a bar graph has the parts that we talked about. It's got a title. It's got the axis label. So here would be the x-axis label down here, the y-axis label going up the side. Going up the left side of the y-axis are units. Notice the units always start with 0 at the bottom. Going across the bottom of the graph, the x-axis are the labels of the independent variables. And notice the bars. Notice how the bars don't touch each other. What we like to say is these are kind of like buildings in a city. There's always space in between them. They're not like stair steps. Finally, it's a good idea to put the unit number on top of the bar. That just takes away all doubt about how much information the bar is showing. A bar graph is often used to compare data. Next, we have a line graph, which we use a lot in the force and motion unit. Again, a bar graph is going to have a graph title. It's going to have a y-axis, which will be the dependent variable, and the y-axis is going to have a label. Going to have an x-axis across the bottom, which will be the independent variable, and again, it's going to have a label as well. The line graph is going to, the line is going to move along. Notice the line on the line graph does not have to start at 0. It's going to start wherever the first independent variable information is. All right? A line that's going down is showing a decrease in number. A line that is going at an upward arc is showing an increase. And lines that are horizontal means the data hasn't really changed from one point to another. Line graphs are often used to show change in data, and a lot of times a change in data over time. This is an example of a speed time graph, and this is a graph that we need to learn how to read and understand. So again, we have the title across the top. We have speed, in this case in meters per second, going up the y-axis. We have time in seconds going across the x-axis. Notice how the units are displayed in the labels. On a speed time graph, when you see a line going up like this, that means the speed is increasing. When you see a flat horizontal line, that means the speed is staying the same. Oh, by the way, increasing speed, we often call that acceleration or positive acceleration. Here we've got where the speed is not changing, and so we would call that zero acceleration. When the line is going down at a slant from left to right, that shows the speed decreasing, and we would call that negative acceleration. Again, here we have no change in speed, positive acceleration, no change in speed. Now, one of the things that you can glean or do from a speed time graph is you can use it to find a speed at a specific point in time. For instance, if we wanted to, we could try to figure out what the speed of this object was at 4 seconds by taking 4 seconds straight up, and we see that the speed was 8 meters per second. And so even though we maybe didn't know the speed at that specific time as we plotted the graph, plotting that information on a graph allows us to go back and find speeds at increments that we didn't necessarily plot.